Or are we on?
Yes, we're on.
Okay.
I'll do the next one.
We're going?
It's already hit play.
Play.
Oh, she already hit play.
Green is recording.
Oh my gosh. I tell them to intro a video and they can't intro a video. Hello, everybody. Welcome to our videos for one of our videos.
We wanted something different, did we not? I think we did a good job at introing. High five.
I don't think they did a good job at introing. They didn't do anything but stare at each other. So, anyways, we're talking constant rates of change with graphs and algebraic expressions
Doesn't
today.
that seem familiar?
It does seem familiar. Haven't we been talking about this for like days now?
I think so.
I think so, but I think they're starting to get it. I hope at this
They've
point.
been doing good.
They've been
This
doing
should
well.
be Tuesday night.
Yes, it should be Tuesday
Yep.
night, unless you're one of those amazing, wonderful students who has watched it early. Woohoo! So our learning target, which I hope you write into your journal. You should have your journal out. It should be open. You should be writing this down. We will represent constant rates of change by using algebraic expressions and graphs. Okay. Pause it if you need it. So given a graph, we have to create the table and the equation. Does anyone else want to do this?
Is this a stamp?
I can help out.
No, this is not a stamp.
No.
Miss Newsom's
I
amazing.
think Miss Newsom needs to do this since she did such an excellent
I
job.
had
Miss Newsom, it's all
Pretty
you.
steady hand
It's all
on
you
that
today.
one.
Go, Miss Newsom.
All right, so here we go. The first thing that I would do, I guess, obviously, that we're working with here that we can see is
You
the
want to do a
graph.
color pen?
Yeah, let's do that. Let's do green.
For green.
A green pen from green.
Would
Okay.
you like blue?
Boom.
No,
Okay.
because green
So,
from green's great.
as you can see, we have a graph, and I hope you see that there's 4 points. 1, 2, 3, 4. The line is straight, which means it's
Linear.
linear. Yay!
You know what? I think it's also proportional.
Why?
Because it went through
The origin.
Oh,
Thought I'd circle that so that you know that that's the origin. All right,
And
moving
can I
on.
say one thing really quick?
Yes.
You will not always see it where there's actually points. We're being really nice to you and giving you the actual points in here. Sometimes you'll just see it where it goes through the line. And
Right,
won't
it'll be a
actually-
grid.
It'll be the
grid. It looks like this, but you will see where they
won't see-
intersect.
Yes, you'll see where it intersects, but you won't necessarily see the point.
I call this a man-made graph, so you
Yes.
have to put those in.
Yes.
We don't.
Today it's woman-made graph.
Ha.
Okay, so as you can see, we have this graph here. We have our line. Let's start pulling points from this graph and putting them into our table. Since there's only 4, I'm going to take all 4 of the points on the graph. You could, if you wanted to, start at 0, 0. Obviously, I'm not going to. I'm going to start down here just to include that point. So I'll put 0, 0 here. Now, remember, when you're looking for your point, what's it called when the points coordinate pairs, you always do your x first, then your y. So we're going to go back to -2, comma, down -2. So it should be -2, -2. Comma's important. It separates the x from the y. We know this is 0, 0. We know that this one we're going to go over 2, up 2. Ooh, that's not very clear, but that's what I meant, okay? And then +4, +4.
That's why I call it a man-made graph, because it's never perfect.
not perfect.
It's
And
not
we make
perfect.
mistakes, it's okay.
Yep.
You gotta
So,
read between the lines.
I have taken the information that I've seen in this picture or graph, and I have placed it into this table. Now, in order to create my equation, I need to find my constant rate of change, or my constant of proportionality, or my slope.
Wasn't there like a formula we used to find that?
Yeah, isn't the constant of proportionality represented by k?
Yes.
Okay.
So K equals y divided by x.
Y over x.
Yes, I
we
totally
know that this
remember
is
that.
proportional because it goes through our origin.
Yes.
Okay, so can I pick any y over any x?
Absolutely, except for 0, 0 because we can't divide.
Obviously, because, yep. So let's
Just
do
throw that out
2 over 2. I took this guy right here. I took my y and my x. What's 2 divided by 2?
1.
Let me just show you. If I take this y and put it over this x, it also gives me
1.
1. Okay? Doesn't matter which pair you pick. So what's my constant of proportionality?
1.
1. So my equation
It's always in the form of y equals kx.
should be in this form.
Okay.
And didn't we just
Find
solve
K?
for k?
Yes.
Yeah. So is it y equals 1x?
You could put that.
Do I have to put the 1?
You don't have to.
So it's just y equals x? Mm-hmm. So anytime
There is,
y
I
is
will put it in though, there is an
something-
invisible one.
Can we just write it again and just put y equals to x so that they know that?
They're equivalent.
Right.
Yes. What?
They can't see it. There we go.
Okay, and
So-
These two are the same.
I just wanted to say something. When you write an equation, you must have your x value and you must have your y value. You have to have an x and y. A lot of you guys are so tempted to fill numbers in for those. An equation has to have it because
your variables.
Because that's when you're going to be plugging in these
Guys,
values.
this is our input, that's our output.
There
So
you
let's
go.
go see this really quick. If I was to plug, let's look at this one, it's clean. I like this one because it's clean. If I go up here and I take my x, -2, if I plug that in,
It has
-2
to
equals
-2.
-2. I got that. I could plug 0 in. 0 equals 0. 2. 2 equals 2. 4. 4 equals 4.
There we go.
Perfect.
Done and done.
Done.
Awesome.
Cool. Ba-dum-bum. Next.
Miss Green, do you want to do the next one or you want me to do it?
You do it.
Okay, cool. We've got y equals 10x today. So we're going from the algebraic expression, which is y equals 10x, to create the table and the graph. I like to start with the table. I know Miss Green likes to start with the table too, so that I can create the ordered pairs. I haven't heard what Miss Newsom prefers if she goes
I think I said I like the graph first, didn't I? I do the graph first.
Oh, I don't remember. I just remember you
I
always put
just
the
love
tables
it all.
first. I love it all too. I can do it from the graph and I can do it from the table. For you guys, it might be easier to create the
It doesn't
ordered
even matter,
pairs.
does it?
Doesn't matter. So let's just start with, if I had, my favorite numbers to put into a table are -1, 0, 1, and 2.
For quizzing purposes, does it matter which one I do first?
Absolutely not.
See,
Because
I like starting with 0.
No.
oh no,
I'm
like
talking
on
about
these, graph or table.
Oh.
For quizzing purposes.
No, whatever you're more comfortable with.
That's
And
totally
some
up
of
to
you
them.
guys, I know you get lost when you're like, I don't know how to graph this.
'Cause I
if
just-
you create that,
I
it's
just might ask this
question.
question during a quiz.
Yeah.
Might be a good.
Hint, hint. Pay attention if you're in Miss Green's
Just
class.
wondering. Anyway, keep going.
So now all I have to do is substitute in my x value. So I've got 10 times -1 is going to equal my y value. 10 times -1 is?
-10.
So that would be -10. I plug in 0. 10 times 0?
0.
Equals 0. It went through my origin. That means it is proportional. Then I've got y equals 10 times 1.
10.
It's 10. And 10 times 2.
20.
It is 20.
Oh, good. I made the graph good.
You did make
Good
the graph
job.
good. And then I know Miss Newsom said she likes to start with 0, 0 here. The reason I like to start with -1 is just because I'm weird and have always been taught.
You want to see it cross
I want
that
to see it
y-axis?
cross that
Yeah.
y-axis. And so I always start with them -1, 0, 1, and 2 because those are the easiest numbers to multiply.
True.
It's only one negative. You guys can handle multiplying by -1.
I hope so.
I really hope so too. So now I have ordered pairs. I've got -1, -10,
0,
0, 0, 110,
220.
and 220. So I'm going to do -1.
It's going to be kind of hard on the -1.
This will be hard. We should have done these as
The
like
X's
1 and
as
2s.
ones.
But that's okay.
That's okay.
So we'll do -1, -10 will be about right here. Then we're going to do 0, 0, which is right here through my origin. 110, which again, 1, 10. You guys do need to see that if your scales are not always perfect, yeah, you've got to figure out about where that 1 is. So 110 and then 220 would be about,
Should be a steep slope.
it's going to be a very steep slope. It's going to go up something like that. Wow, that was a really bad line. I'm sorry.
Let me see if I can make it. Ready?
Here, real quick. I mean,
Do it in green. Oh yeah, that's perfect. That was
if
perfect.
it's
line.
okay with you,
Yeah.
can I just? We're just gonna.
And
make
we'll just
it a
do the
little,
10, 20,
Yeah, we're just gonna make it a little bit bigger. Just
30.
To see it.
Yeah.
So you can kind of see this now. So it'll be, you know, if
-1,
you've got
10.
-1,
1, -10.
-10,
0,
0, 0,
1, +10.
1, 10, and
All we
2.
did is we zoomed in just a
Yes.
little bit.
That's
so you
all
can
we
see-
did. Yeah.
So you can see it a little bit.
Ooh, it's straight. Don't look at the curve. It's straight.
And I gotta tell you this: on any quiz or test, you want to draw as many points in there
Yes.
on your intersections because otherwise your line won't be as straight as it should be. So
Yeah.
just make sure that when you are graphing anything, make sure that you go all the way across.
It's more accurate too.
Yeah. Just,
yeah.
In other words, we would have gone to 33 all the way up.
Right.
However,
It keeps going on this line.
use
right
your
here.
graph. In other words,
Yes.
use the whole graph.
So anyways, that's from a graph and an algebraic expression. That's it. We are
Have a
out for
great
today.
night.
See you later.